Okay, we're going to start looking at units and how to do conversions, but before we do that, we want to understand what the metric system is and how to use it. The metric system was developed around 1900 by a team of scientists who said that the current English system is a mess. It's hard to use. And all of the countries in the world have adopted the metric system as their only measuring system. The United States has doggedly retained the English system. So you've grown up using the English system, but you need to learn how to use the metric system because this is the standard in medical and science areas. Every time we write a number, we are going to write a unit behind it. So focus on the units. Units mathematically direct your problem. So if you focus on the units, you will find the problem is a lot easier to do. Currently, in your math classes, they don't use units and they focus on the numbers. So you're going to have to change your mindset to look at the units first and then look at the numbers and sort that out. So please pay attention to this. Focus on the units, let the numbers follow. These are English units that you're very familiar with, and the metric units. Notice mass, what we weigh things in. What are the metric units? Gram, kilogram, milligram. Notice it's all based on gram. Length, meter, centimeter, kilometer, all based on meter. Volume, liter, microliter, milliliter, all based on liter. Then we have cubic lengths like cubic centimeter, cubic meter. Area, which would be squared length and squared meter. So these are the dimensions and the units that are associated with them. Now, something that will help you is realizing that when you have the word per in a mathematical problem, all of our problems are going to be word problems. So if it says per in the words, that really is translated as divided by. Any units that come after the per are going to be in the denominator. So it might say 2.21 pounds per kilogram. So we express it like this. 1.1 per cent. So it's 1.14 over 100. 125 milligrams per kilogram. So we put the kilogram in the denominator. 200 milliliters per hour. If there are two units, for instance, it might say 125 milligrams per kilogram per hour. Anything, or 125 milligrams per kilogram hour, if it comes after that per, then put it in the denominator. The metric system uses powers of 10 and the base unit. So we often will use the base units all by themselves, but many times we'll use a prefix, and that prefix has a meaning of a power of 10. So we have gram, meter, and liter, and in combination with them, we have kilo, deci, centi, milli, and micro. I'm using these prefixes because those are the ones that are most common and the ones that you see in the medical area. So even if you're not going into nursing, you will find this anytime you have healthcare issues. You will be finding these prefixes associated with the units in the medicines that you take, for instance. So what does kilo mean? It means 1,000. What does deci mean? 1/10. Centi means 1/100th. Milli means 1/1000th, and micro means 1/1,000,000th. This little mu here is the symbol that scientists use, but the medical area has found that when people handwrite a mu, that it looks like an M, and so people get milli and micro very much mixed up. So the medical area has changed the micro prefix to be MC, and that's what I'm going to be using in class and on exams. So MC stands for micro, and it means 1/1,000,000th. Okay, so you can either use the power of 10 or you can use these decimal or the thousand in as the meanings of the prefixes, whatever you're most comfortable with. And how do you use these prefixes? You use them according to their meaning. So take note right now. A lot of people skip over this and they get confused, or they think they know this, how to write the relationships already. But what I find is most people in the class have a very fuzzy understanding of the metric system, and they have a slippy slidey decimal system that is no good to use in here, because what I find is people slip and slide the decimal the wrong way and sometimes the wrong numbers. So learn the system, get comfortable with the metric system, and eventually you'll be able to go away from the system of the very basic way that the metric system is used. Because kilo means 1,000, you can just go ahead and write kilo equals 1,000. And this is the most secure and safe and correct way. You always get the right answer if you do it this way. So write kilo equals 1,000. Notice I left a space on this side of the kilo, and I left there's of course a space after the thousand. Now all I have to do is put meter after kilo and meter after 1,000. This is mathematically correct because if I multiply both sides of an equation by the same thing, I haven't changed the equation. So now you see that kilometer is equal to 1,000 meters. And I can use that in conversions. Using this method that I just showed you, what I want you to do is try the same thing for how many meters are in a decimeter, how many liters are in a microliter, and how many grams are in a milligram. So go ahead and pause the lecture and do this, and then start it up after you've finished it. So deci equals 1/10, so decimeter equals 1/10 of a meter. Micro equals 1/1,000th, so microliter equals 1/1,000,000th of a liter. Milliliter, a milli equals 0.001 or 1/1000th, so milligram is equal to 1,000th of a gram. So now we can get these equations and use them in doing conversions. If you learn how to do this simple thing, it's going to make the next steps very easy. Do know that a pound is equal to 454 grams, or know that a kilogram is equal to 2.21 pounds. You can learn both of them, but know at least one or the other. And I expect you to know that in doing conversions on an exam. Realize that a milliliter and a cubic centimeter are the same thing. They defined that a centimeter times a centimeter times a centimeter as being a milliliter. And the old people in the medical area are going to say a cc instead of a milliliter. When they say cc, they're talking about a milliliter, so don't let that confuse you. The last thing that we're going to need to learn about some new units are the temperature scales. We will be using Kelvin when we get to gas problems, but right now we're not going to be using that much. What I expect you to know is the Celsius system. Now, I am not going to be giving you a temperature in the Fahrenheit system and asking you to say what it is in the Celsius system and vice versa. What I do expect you to know are these four temperatures: the melting point of water, which is the same thing as the freezing point of water, which is 0 degrees Celsius. Room temperature, which is approximately 25 degrees Celsius. That's considered standard room temperature in the metric system. Body temperature, which is 37 degrees Celsius, and then the boiling point of water, which is 100 degrees Celsius. So you need to operate in the Celsius system as if you lived in it all the time. So if I were to ask you what would be a reasonable temperature for a cup of hot coffee, You wouldn't say 200 degrees Celsius. You wouldn't say 150 degrees Celsius, nor would you say 0 degrees Celsius. You would come up with something like 80 degrees Celsius. Now, I'm not going to ask you for an exact temperature because cups of coffee are all over the place in temperature, but a reasonable one, I expect you to know. That's the type of question I might ask you.